This video shows you how to use a circular saw, how to select your blade and the dust extraction, as well as health and safety tips and how to make diagonal cuts on plywood. And here, the power tool that we've got is the Guild 1400 watts 185mm circular saw. The table saw is at the very core or epicenter of the woodworking shop. And at the very core of your table saw is your blade selection. Suffice to say, the blade selection is crucial or pertinent with regards to getting quality cuts. And so the big question is, why have we opted for a circular saw? Firstly, a circular saw is handheld, whereas, a table saw is stationary, is lays flat. The circular saw is budget friendly. The table saw is slightly more expensive. You can make fewer cuts when using the circular saw, but with the table saw, you can make more accurate cuts. It's quite messy when you're using, the circular saw, with sawdust, but, the table saw tends to be a lot more cleaner. If blade selection is pertinent or at the very core of getting quality cuts, then we must be able to decipher or interpret technical data that is associated with the cutting blade. Technical data or jargon isn't as daunting as it seems once you get the hang of it. For the Guild power tool, we've got a blade size of 185mm, a blade bore at 20mm. It's got a cutting capacity of 90 degrees at 65mm and 45 degrees at 45mm. So it essentially means, it can cut at various angles up to a depth of 65mm or 45mm, depending on the angle. And also a bevel capacity that's capable of doing cuts, from anywhere between 0 to 45 degrees. So it could be 0, 15, 30 and 45 degree cuts, okay? At a later stage, I will be showing you how to set, the depth that you want to cut and the angle at which you want to cut, okay? But first, let's get conversant with all of this data. If you juxtapose the technical data information side by side with the information that you've actually got on your blade, we can instantly begin to see that there is a correlation. 185 being the actual blade size or the size of the rim, 20mm being the blade bore, which is right at the center of the blade, and 2.4mm is the thickness or kerf of the blade. At a later stage, I will show you how to adjust your cutting and bevel capacity. The next step would be to familiarize with other work tool components. When I push on the lower guard lever clockwise through the fixed guard, it reveals the bottom of the blade, and you can see that it is being rotated in the direction of both arrows earlier highlighted in the aforementioned. To change your saw blade, you need to take out the blade bolt and the outer flange with an Allen key, which then reveals the blade bore, the saw blade, and an inner flange behind it. Just remember that when fitting in a new blade, that the saw blade must be sat on the inner flange, okay? Suffice to say, the saw blade must be sandwiched between the inner and outer flange, with the blade bolt coupled onto the outer flange, okay? The tip of one tooth to the tip of the next tooth is called the step, while the gullet is the space in front of each tooth. Just take cognizance of the gullet, the size and its depth determines how much wood can be removed during cutting. In general, if a saw blade has fewer teeth, the speed rate will be faster and it will have a larger gullet size. And larger gullet sizes are most suited to rippling applications. But if you've got more teeth and smaller gullet sizes, then it's more suited to cross-cut applications. I'll show you what I mean in a minute, okay? Economy blades almost always have a thin stamped steel plate with expansion slots that end bluntly in open holes, which is what we've got here. The open hole exudes or signals old technology, and a noisy blade. It's got a 2.4 kerf, a 20mm center bore, and a 185mm rim size. And so this is the center bore. You undo it with an Allen key if you want to change the blade. Okay, so again, that's your rim size at 185. Your center bore is at 20 mil, and your Kerf is at 2.4. This blade has got 24 teeth, and it's got large gullet sizes between the teeth, which means that it can be used to move out big chunks of wood. 24 teeth typically connotes a ripping blade, and you can see on the blade it's highlighted that this blade is designated for cutting wood. You also have to wear your ear protection or muffins, your face mask, eye protection or safety glasses. Just pretty much take health and safety precautions and ensure that you read the instruction manual. The National Institute of Occupational Safety and Health recommends that hearing protection must be worn when operating tools with a sound pressure level above 85 dBA or decibels noise level. And you can tell this is going to be a noisy blade because it adopts the open technology, here. The long-term goal of Niosh is to reduce the noise-induced hearing loss in occupational settings. And so, if you want to choose a quiet blade and the appropriate hearing protection, you can check the Niosh database for recommended sound power levels in terms of vibration of the work tool, as well as the sound power levels for the loaded and unloaded conditions of the work tool to choose the appropriate hearing protection and to estimate the noise exposure. The blade installed has got a small teeth, and the tooth configuration is an alternate top bevel. The stamped blade doesn't categorically state the hook or rake angle, neither does it state the bevel angle, but we can assume that the alternate top bevel angle is anywhere between 10 to 20 degrees typical. And that's because an alternate top bevel, which is used for all-purpose ripping and cross-cutting, typically has, a bevel angle of anywhere between 10 to 20 degrees typical. The Kerf for each tooth is about 2.4 mil in thickness. And here you can see that the blade, which is usually protected by the lower blade guard, extends below the base plate. And you can see that the blade has got large gullet sizes between each tooth. The ATB, or the alternate top bevel, is suited for ripping. The 24 teeth is suited for ripping, but it essentially isn't suited for cutting strips from hard plywood. So we can see that this ripping blade has got a positive rake angle of anywhere between 0 to 20 degrees, and that's because you can see the inclination of the teeth or tooth. You can also use a flat top grind, an alternate top bevel, or a TCG configuration for rip blades, but for hard plywood you will be better off getting a combination blade or a composite blade. And that's because the grain structure on your hard plywood is not uniform, it's haphazard. And so, your composite blades or your combination or general purpose blade will do a pretty good job of ripping and cross-cutting at the same time. So, what quality of cut can we expect if we proceed to utilize this ripping blade to cut strips from the hard plywood? I'd be expecting, a somewhat poor quality cut, with excessive tear out in certain places. I would also be expecting overheating, okay? So, I would be using it to get the job done, but not overly extensively, as I do not want to compromise on the integrity of the blade. I would try as much as possible to keep my hands steady, whilst cutting strips off of the hard plywood. And I will also be adding 3 mil to the depth of my cut so that the blade can cut through the hardwood plywood material at the base here. And with the open technology, around the rim of the blade, as exemplified at the base here, you should be expecting a very noisy operation of the work tool, okay? As this is not a quality blade, it is an economy blade. So just a quick recap, when you're trying to get quality cuts, the blade selection as well as the type of material that you want to cut is very important. Here we intend to get strips off of hard plywood, and so the ripping blade with latch gullets, or the open hole technology isn't the ideal blade for getting strips off of hard plywood. You should be getting a tooth configuration that's got the ATB, which is the alternate top bevel, as well as a combination composite or general purpose blade due to the grain structure of the hard plywood. As previously highlighted, the vacuum adapter goes to one end of the coupling and the hose goes into the other end. Adjust, the mechanical fastener appropriately, until you get, a tight fit, on the vacuum adapter. Once the hose and the vacuum adapter have been adequately secured onto the coupling, then you install the vacuum adapter with 2 screws onto the circular saw, just like I've done here, onto the fixed guard. So we have fastened the vacuum adapter onto the dust extraction outlet, onto the latches, onto the fixed guard with 2 screws. And prior to this, connected directly a suitable vacuum hose to the adapter. The bevel capacity of the circular saw is anywhere between 0 to 45 degrees, and to use this we need to turn the base plate bevel lock in an anti-clockwise direction to loosen the angle scale. The base plate angle scale reads anywhere between 0 to 45 degrees. Tilt the base plate away from the tool until the required cutting angle is adjusted on the angle scale, and then subsequently tighten the bevel lock by turning it in a clockwise direction. Do not use the depth of cut scale when making bevel cuts due to the possible inaccuracy. Here the bevel cut is set at 45 degrees, and you can see that the base plate is tilted away from the tool. Suffice to say, the bevel cut capacity is anywhere between 0 to 45 degrees. You can cut 0 degrees, 15 degrees, 30 degrees, and 45 degrees on the bevel, okay? So basically just undo the bevel lock anti-clockwise, toggle through the angles that, meets your bespoke requirements, then, to turn the bevel lock clockwise to secure or confirm the angle that you want to, cut through. And for the depth of cut, if we lift the lower guard lever to reveal the lower blade guard, it reveals the blade, and when we visually inspect the blade, we can see that the blade is too far out, from the base plate. And that's because we do not need all of that, blade protruding from the base plate if we're just cutting, a hardwood plywood of about 12 mil. And here you can see that, the blade protrudes from the base plate, so the depth of cut is definitely greater than 12 mil, which is the hardwood plywood's thickness that we want to cut through. To reduce the depth of cut to 12 mil or 15 mil, we lift the depth of cut lock lever and raise the saw body away from the base plate. And straight away on visual inspection, we can see that the depth of cut skill's limit is up to 65 mil. Okay, that's the upper threshold value range. Okay, so what we want to do is to set the depth of cut with the skill to about 12 mil, which is the thickness of the hardwood plywood that we want to cut. Okay, best practice would be to always add 3 mil to the depth of cut so that the blade can comfortably cut through the material. So although we want to cut 12 mil on the hardwood plywood, we will be adding 3 mil to the 12 mil, which gives us 15 mil, okay, so that the saw blade can easily cut through the hardwood plywood, okay. And so here I will be reducing the maximum degree from 65 to about 15 degrees on the scale. And so this is what 15 degrees looks like. Initially it was 65 degrees, and you can see that it's got too much clearance. So I'm going to reduce that to 15 degrees on the scale. And once it's 15 degrees on the scale, I will push down the lever down to lock in position. And so the cutting capacity for the blade at 90 degrees is 65 mil, and if you have the cutting angle to 45 degrees, it can only cut up to 45 mil. Suffice to say, if you set the depth of cut to 65 mil on the scale, it would provide a cutting capacity clearance of 65 mil below the base plate at 90 degrees. 45 mil on the scale will yield a cutting capacity clearance of 45 mil below the base plate. And at 0 mil, the cutting capacity below the base plate is significantly reduced. And so basically, we have set the depth of cut in line with the thickness of the hardwood plywood that we want to cut. If you don't know the thickness of the material that you want to cut, just set, the blade beside the thickness of the material directly, just underneath the base plate, and then subsequently adjust the depth of cut scale accordingly. And once you have set the depth of cut, just slightly beneath the thickness of the material, push the lever down to lock the depth of cut into position. Before you proceed with this operation, make sure that you're wearing the appropriate safety glasses, an approved face mask, and ear protection. For health and safety reasons, you don't want damage to your hearing, you don't want respiratory issues, or getting carcinogens into your respiratory tract. So protect your eyes from foreign object debris. Health and safety is very important. The next step of the process would be to carry out a risk assessment with regards to slip and trips. The next step of the process would be to cut in line with the markings on the underside. Set the base plate of the working tool on the underside of the plywood, right at the lines of the markings. Get the saw blade spinning right before it engages the plywood, whilst the base plate, is sat flush on the underside of the plywood. Do not start the working tool right where the saw blade engages the wood. Always hold your saw firmly with both hands when operating. You need steady hands when trying to cut through the hardwood plywood. Your switch is locked off to prevent accidental starting. Your working tool has got a safety on and off switch. Firstly, depress the lock off button, and then subsequently depress the on and off switch. After depressing the on and off switch, release your hands from the lock off button. The switch is now on from here onwards. To switch off, just release your hands from the on and off switch. The blade may continue to rotate after switching up, so just wait until the tool comes to a complete stop before setting down the work tool. Ensure that the saw blade is not in the way of the cord or wire, and that you're slightly offset, from the working tool when cutting through the plywood. The most probable root cause of why the saw blade has stalled or binded is because it has deviated from its line of cut or wavered during the cutting process. Suffice to say, cutting at an angle. Or it could be that, the work tool was leaning on either side of the cut work pieces, where we were trying to make diagonal cuts, thereby causing binding. If this happens, do not pull the work tool, from the wood piece. As earlier highlighted, just release your hands from the on and off switch. Like I said, the blade may continue to rotate after switching off. Just pretty much wait until the tool comes to a complete halt or stop before setting down, okay? After which, you can reposition, the working tool, along its line of travel or linear travel, okay, ensuring that the blade doesn't rest on the wood and it's free spinning, whilst you're trying to retrace its line of travel. You can start at, at the very initial position where you started making your diagonal cuts, or you can start off, at the position where the saw blade stalled. But if you're experiencing difficulties, from the stalled position, you can start from the initial position and retrace your line of travel, all the way through whilst making your diagonal cuts. So I will replicate the process, of cutting through your plywood when you're halfway through. So here you can see that, I'm providing enough room for the saw blade to spin, prior to cutting, halfway through the plywood. At this stage, I have ascertained that the blade isn't angled and, it's free spinning. So I'll proceed, to finish off, the cut, as I am pretty confident that the saw blade would not be latching or cutting into the sandwiched sides of the hardwood plywood. Just make sure there's enough room and it's not picking on the sides of the plywood before you proceed to finish off, your cut through the cut line. This is the first cut, and it's not an entirely smooth, fine quality cut, but at least we know what our do and don'ts are. And please do note that other less probable kickback causes could result from overheating, which causes the blade to warp, blade dullness and unguided cuts, sap build up in the blade, and lastly, incorrect blade height. So let's visually inspect, the diagonal cuts to see if we've got, fine quality cuts. And straight off, you can see that, it's not a very fine or pristine quality cut. And, there are a host of reasons why this has happened. Firstly, you can see that, the blade bent at an angle. We kind of wiggled and, we didn't accurately have a continuous cut. It wasn't a linear cut. And as such, the blade binded in the sandwiched edges of the plywood. Secondly, the blade selection isn't spot on. Okay, we have selected a ripping blade here, which is much suited for ripping applications as opposed to applications for veneers like your plywood. A combination or general purpose blade would have been more suited for your hardwood plywood, as cutting or making diagonal cuts on the plywood involves ripping and cross-cutting at the same time as you cut through its line of travel. Click on the link in the description or at an earlier part in the video where I kind of discussed, blade selection with respect to your hook angle, your bevel, the number of teeth, the tooth configuration, and what blade is suited for what material. Okay. The next step of the process would be to repeat and reproduce the process, replicate the process, not that we know exactly what we're doing, to get, finer quality cuts from the ripping blade. A workman is only as good as his tools, but we're just going to try and get, good quality cuts from the ripping blade. But, if we wanted optimal quality cuts, then, your combination blade or your general purpose blade, is the way to go, as they are capable of producing the finer quality cuts that you see on the side of the hardwood plywood. So we are going to make more diagonal cuts, but ensuring that, our hands are sturdy, we're not deviating from the cut line or the line of cuts, we're not wiggling, we're not, putting pressure, of the work tool onto the material that's being supported by the poles of the rack, whilst ensuring that our saw blade spins freely before it engages the hardwood plywood, and if possible, engineer a continuous cut. So the next step of the process would be to replicate and run the saw blade through each subsequent work piece line of travel. And as you can see, this is a much better cut. So we're going to replicate the process again and cut this hardwood plywood into 4 pieces diagonally, from both ends. Reclamp subsequently and replicate the process on the half cut plywood hardboard. And like I said previously, make good use of your safety lock-off button, okay, to prevent accidental starting. And when ready, press on the switch or the trigger. Make sure that, the saw blade has enough room before it starts, cutting through the wood. And cut linearly, continuously along its line of travel, or along the pencil mark that you've lined up on the hardwood plywood. The next step would be to rework the plywood hardwood piece where we had, the binding or the kickback from the work tool. Just strip off, the side to get a finer quality cut with the circular saw. And trust me, this stripped off bit is not the best looking piece on camera, but it looks a lot better, in person when you actually visually inspect, the stripped off piece. And as you can see, it's not the best looking quality cut, aesthetically, but it's better off than the binded cut that we had previously. At best, the blade has just done a slightly below par of medium cross cutting and ripping, of the hardwood plywood. A combination or general purpose blade would have done a much better job with respect to getting quality cuts. Once done, place the working tool on its underside. Despite the fact that we've got a lower blade guard to protect the blade, you don't always want to be placing a working tool where you've got the blade, because that could damage the blade accidentally. Okay, you can store the coupling away or leave it installed on the vacuum adapter, okay, provided you haven't got the hose on it. That's fine if you regularly use your circular saw, but if you don't, just store the coupling away on its own or as a standalone from the circular saw. Then subsequently disassemble the coupling from the vacuum adapter by undoing them knots. And whilst undoing them knots, if the clips on the coupling, disengage fully, bring them quite close to each other and tuck tight in the screw, and the clips should get back into position. Click on the link in the description for quality blade, material and tooth configuration selection in order to get quality fine cuts, as well as dust extraction, configuration or customization, how to use the power rail guide and risk assessment when using your circular saw. And that's about it really. If you found the information useful, don't forget to subscribe, like and share, helps the channel grow, and hopefully catch up with you later. Goodbye.